Hello, in this lesson you're going to learn how to prove statements about line segments. We will start with the title of our lesson, which is going to be segment proofs. And we have some vocabulary. The substitution property of equality is when you substitute one value with another. My definition that I will give you is if the values of two quantities are equal, then you can replace the value of one quantity with the other. Okay? And my next definition is the segment addition postulate. This states that if point B lies on line segment AC, then AB plus BC is equal to AC. So let me draw that for you so you can see what that looks like. Okay, so I've got line segment AC and point B is on that segment. So this just means that this part, AB, plus this part over here, BC, is equal to the whole thing, AC. It's just saying that you can add segment lengths together to give you the whole segment. Okay, the next one is the definition of congruent segments. This is very interesting. It's odd that they gave this a name, but they did. This states that if two segments are congruent, then their measures are equal. So think about that. If two things are congruent, they're also equal. Yeah, that makes sense to us. Let me draw that for you. Okay, so here's an example. If you have segment AC and it is congruent to segment BD, then the measure of AC is equal to the measure of BD. Do you see how when you say they're congruent, you put the line over on top of the two letters, but when you say that they're equal, their measures are equal, you don't put a line on top. It's just some of the notation that's used in geometry. Okay, and then the last one is very similar to the definition of congruent segments. Definition of congruent angles states that if two angles are congruent, then their measures are equal. It's the same thing, and I will show you an example of what this looks like. So if I have, for example, if I have angle A and it happens to be congruent to angle B, then the measure of angle A is equal to the measure of angle B. So before I say that the angles are congruent, now I can say that the measures are equal, or I can reverse these. It's still the definition of congruent angles. If the measures are equal, the angles themselves are congruent. And this is the best way to explain the difference between equals and congruent. The actual measurements are congruent, or equal. The figures themselves are congruent. So we have some examples that we're going to do. We have two examples to do. The first one states, use the figure at the right and the given information to prove the statement. So we are going to prove that 2AB, two of these, is equal to one of these, 1AC. And we have some information over here. So let me start out with, this is a proof. And we're going to give some statements and some reasons. Okay. So the purpose of our lesson today is not to be able to prove statements like these. The purpose is actually so we can learn some of this vocabulary and understand how it's used. The first thing we're going to do is write down what's given. C is the midpoint of BD. Okay, and B is the midpoint of AC. Okay, and this information was given to us. Okay, the second step is usually to use the given statement to say something else. So logically, what comes after this? If C is the midpoint of BD, then BC, this segment here, and CD are congruent to each other. We're going to go ahead and say BC is equal to CD because C is in the middle of B and D. And the same thing is true of the second statement. B is in the middle of AC. So AB is equal to BC. And this is, the reason for it is definition of midpoint, because that's what a midpoint is. It means you're dividing up a segment into two equal pieces. Definition of midpoint. Okay. The next step, so what we did was we used the given statement to come up with something else. The next step is going to come out of nowhere. We are going to use the segment addition postulate. So now that I've ran out of things to do, the given statement, I've already translated that into equations. Now I'm going to come up with two more equations based on the segment addition postulate, and this is the way it's going to go. You see this segment AC here, it's made up of AB and BC, so I can say that. I can say AB plus BC equals AC. And I can say BC plus CD is equal to BD. Okay, so that's this other segment up here. BD is equal to BC and CD. Put those together, you get BD. These two statements that I wrote, this is called the segment addition postulate. So it kind of seems like it came out of nowhere, but it really didn't, because the answer has AB and AC in it, and the two equations that we've already written don't have AB and AC. I need to somehow find a way to put AC in an equation. What I've actually done is I have something really close to this equation. See, AB plus BC. Okay, over here, the left side has AB. The right side has AC. I'm just missing one of these other ABs. Okay, so now I can actually replace this BC with an AB because BC is equal to AB. So I'm going to say AB plus AB equals AC. AB and BC are equal. We already said that. So I can replace one of them. I can substitute. This is called the substitution property of equality. Okay. And the last step is this, what I have here, looks really close to this. The only thing that I want to do is I want to say 2AB is equal to AC. And all I did was combine some like terms. Because AB plus AB is 2AB. So now that we have this statement, that's what we were trying to prove, we're finished. We have proven what we were trying to prove. Okay, we have another example. This is the last one. It says, use the figure at the right and the given information below to prove the statement. So we're going to say, we're going to write a proof. We're going to have statements, and we're going to have reasons. Okay. And I'm going to write down what was given to us. AB is congruent to DE. BC is congruent to EF. This was given to us. Okay, that's the easiest part of this proof. We're trying to prove that AC is congruent to DF. So this whole segment on the top is the exact same length as this segment on the bottom. Okay, and then the given information says AB and DE are congruent. BC and EF are congruent. Well, that makes sense. If this piece and this piece are congruent, this piece and this piece are congruent, the two whole segments are congruent to each other. So what we're going to do is we're going to use the given information first and state that these two measures are equal to each other. AB equals DE and BC equals EF. That is the definition of congruent segments. If they are congruent, then their measures are equal. Okay, segments. And then the next thing we're going to do is something odd. It kind of comes out of nowhere, but it works. I can see that AB and BC put together gives me AC. So what I'm going to do is I'm going to add these two purple equations together. And I'm going to write it up here so you can see it better. AB equals DE, BC equals EF. When you add them together, the left side is AB plus BC, and the right side is DE plus EF. Okay? AB plus BC equals DE plus EF. All right? And because we added two equations together, this is considered the addition property of equality. Okay? We're actually almost finished. There's 6 steps, so we're halfway to the end. The next step, let's see if I can get this to make it so I can see it better. In the next step, we are going to use the segment addition postulate. We're going to say that AB plus BC equals AC. And we're going to say that DE plus EF equals DF. This is called the segment addition postulate. Okay? The next thing we're going to do is some substitution. So, I see that I want this to say AC is congruent to DF. That's what I want. I have an AC, this is equals here. I have DF. I can substitute AC over here and DF over here. That is substitution. Okay? And the last step is, if these are equal, the segments themselves are congruent to each other. This is the definition of congruent segments. Okay? And we have proven what we were trying to prove in the first place. All right. Thank you so much for watching.